Hi there and welcome back to part 3 of Data Lake in a Day. So this is the day you've all been waiting for. This is we're actually going to do some processing of the data. We've already ingested the data in lab 1, then we've ingested some weather data in lab 2 to go with the sales data, and then in this lab we're going to take all of that and we're going to create a data model. So what this actually means in reality is joining up those tables, connecting them in a way that we can then later use to either visualize or analyze the data in some way. And this is pretty standard in data warehousing. The difference here is that we're doing it from files on a lake and we're going to create the model on the lake. And the reason we're going to do this is it's going to take a few minutes to process. In this solution, we are only turning on the processing power while that processing is happening. This means that we don't have a very large cluster constantly there costing us money. We haven't spent $100,000 on buying hardware or setting it up. We don't have any maintenance. We literally just design this data flow, and then whenever it runs, an appropriately sized cluster is going to start up, run the processing, write the files out to the disk, and then we're going to stop that processing. And then later on, we're going to pull it into another product, Synapse DW, so that we can then use that product to kind of query it. That's our presentation layer. And beyond that, we're then going to use Power BI. But for now, we're just creating the model. So with that, I hope you enjoy the demo. If you do, please hit subscribe down below, hit the like button, and look forward to sessions 4 and 5, which will be coming up very soon now. Thanks very much. Enjoy the demo. So first thing that we're going to do on this lab is to download some data. We're going to do that because the data that we generated in the previous lab won't line up with the trial sales data that was created for the lab. So we're going to have to use the data provided. So first things first, click on the link, download Azure Storage Explorer, and then click on the next link to download the zip file with the actual data in. We're going to run through the Azure Storage Explorer installation routine. This will just take a couple of minutes. While that's happening, you can separately download the weather data. Obviously, some of this is sped up on the video because it's fairly tedious just watching me download and extract some data. So all that's in here is a bunch of data for the various cities that are in the sample data in the sales database. So I've created weather data for all of the cities where there is some sales data. This will then allow us later on in the labs to see that weather data tying up with those cities and the orders. So once you've logged in, find your weather CSV folder. What I didn't do on the video is to delete the existing 4 files. Make sure that you're doing that. Very important, because otherwise they cause some issues with the data later on. And once that's uploaded, we can move on to setting up the data factory. And this is the part where we actually start to change the data, modify the data. So go back into your designer, and we're going to create a new pipeline for this. And here we're going to call it pipeline data prep. And this is where we're going to copy that sales data and consolidate it. And then later we're going to create the main kind of data flow mapping. So first things first, put a copy job onto the canvas, and we're going to have our source will be delimited text. And we're creating new sources here. We wouldn't normally have to do this. We can reuse the ones that were used elsewhere. That in a real situation is going to be down to the design of your pipelines and that kind of thing. Here we're doing it just for convenience because it's easier for instructions to follow so that you can easily see what's happening. So we're going to go into the raw/weather CSV, and we're going to get all files ending in star.csv with a wildcard. Then we're going to set up a sync, And this time we're not going to go to raw, we're going to go to the same blob storage account, but this time we're going to go to a different folder called model, or different container rather. So this is where we're going to put our data that we will later consume. The actual structure of a lake I will discuss in other videos. This is so that you can see that on the one hand we've got data that came from a system, was the original record, and on the other hand you've got data that we've modified. In this case we've got CSVs coming in, and we're transforming them into CSVs. Obviously there are other formats, as I discussed in session 2. But effectively we're taking something in a CSV, just like an Excel document as you would know it, and we might be renaming those columns. We might be taking different columns from different sources and putting them together. And this is essentially what we're doing with our modern data platform, is just transforming things, but it means that we can do it at a very large scale. So here all we're doing is copying from one place to the next. So we've published that pipeline and we're giving it a run, and then we can actually see the if we go into the container, into that model folder, we've just consolidated hundreds of CSVs into one CSV file. So you'll remember that the incoming data was coming in a JSON format. We were creating our own CSV off the back of that in lab 2. And now in this lab, we're taking the CSVs that we had, one per day. We're just consolidating those down so that we've got a larger file to work with more data in it. And that's just for an efficiency reason on the lake. And in this demo, it's to show you how these things can happen. So next, we're going to create a data flow, and it will be a mapping data flow. This is going to allow us to actually transform our data. We're going to take in multiple sources, we're going to output multiple sources, starting with the customer source data. So here we're going to just select the delimited text customers data coming in, and we're going to import the schema so that data flows is aware of what columns are actually available in there. So we didn't do that earlier because we didn't need it for lab 1 when we were creating these. And off of that, so when we click the plus here, these are all the actions that we can take against that data source, and the data does flow from left to right on the screen. So we're creating an aggregate, and here we are effectively trying to get a list of all of the cities that are within our data. So we're going to look at the source customer data, and we're going to do a group by, just so that we can consolidate it down. So this is sort of a workaround to just get that list of cities. So this is getting an aggregate, and it's going to count the number of instances that city comes up, and then we're going to use a select statement, and we're just going to remove the count information so that we're left with a list where each city appears exactly once that was in our original data. And what I didn't do here is actually hit the delete button on the right hand side, which would have removed that. Sometimes I miss steps in these videos. It's fairly time consuming to get it exactly right and running through this again and again. So apologies for that. So we're adding a sync. This is the same as we were doing with syncs previously. We're going to create a delimited text sync and going to put it on the same blob storage account. And we're just going to call it model cities, to note that it is going into to the modeled area of the lake. This is final data that we're going to be consuming later on, and we're going to put it into the container model, and then we're going to create a folder called cities because we want to export into a single file, but we want to overwrite that every time. So here we're going to call it cities.csv. And we're going to tick clear the folder. So before this job starts, it will delete everything in that cities folder, and then it's going to create a single file called cities.csv, which has the current full list of cities. We wouldn't necessarily do it this way in a real solution, but sometimes if you've not got too much data, it's just convenient to completely rewrite the file every time. And sometimes it actually performs better than trying to add to an existing file. So next we're going to branch off of the same source customers. So you can see now we've got source customers up twice just as a second branch. This means that we can do multiple things with that same data. And behind the scenes, Data Factory is going to optimize these processes so that it will read that data in once and then do multiple things with it. It's not going to read it in twice. So here we're just going to take the incoming customer data and write it directly to the outgoing customer data so that we've got a full fact table around our customers. We wouldn't necessarily really do it this way either. So normally we would have just written it out into the model area in the previous job. But again, the labs have been designed to be kind of self-contained so that you can see everything that's happening in one area. So we're doing a few things just for convenience here rather than because they're strictly necessary. So we've then added in the source order items. This contains the actual detail of customer orders, and we're bringing that in from the CSV that we put in lab 1. And again, we're going to do the aggregate thing so that we can find out a list of all of the items in the data set that were ordered within the orders that we've got recorded. So if you were to look into those CSVs, you would find orders for various things. I think it was shopping, kind of supermarket type stuff. And you would see lots of orders for instance, carrots. There'll be 5 or 10 different orders containing carrots. What we're doing here is just pulling out the fact that somebody somewhere has ordered carrots, and therefore we're going to get a dimension table out of the back of this, which will just list all of those things so that we then have a list in Power BI. We can then have that as a drop-down list, or we could have that as a legend on a graph, so that we can find these things nice and easily. So again, we did the select unique items, and we're going to use the sync to just output the list of items. Again, to blob storage, again, we're going into that model container, and again we're going to write it out to a single CSV. So as you can tell, this is pretty repetitive. Part of the original kind of aim of this course or this workshop was to show it's very, very easy to create a data lake. It's very, very easy to transform the data. None of this is difficult stuff. It's quite time consuming sometimes though. There are techniques to automate some of this and that kind of stuff. There are tools out there that can do some of these steps automatically as well. And the actual data model that we're creating, that is obviously the hard bit. And you're going to want somebody that understands how to create the model and what kind of model they're going to want and all of those kinds of questions. There's a whole branch of kind of IT that deals with this. But for the sake of should I create a data lake, how hard is it going to be to create a data lake, what can I get from a data lake, this workshop is designed to answer those questions. So obviously it's not going to take very long, it's not going to be overly expensive, and I hopefully have explained clearly all the way through that most of these things are fairly cheap components. A lot of the processing power is not switched on all the time, so it can be cheaper than on-premises traditional kinds of solutions. And also the way that we're processing means that we can scale it outwards, which means that we can finish in a reasonable amount of time regardless of the amount of data that's coming in. So again, here we are bringing in order data, just as we did with the other data sources. This time we're creating a new data set because the original orders data set had some parameterization on there. So for convenience, we're creating one. We're joining this though to the order items table. So this is something new that we didn't do above. And what we're doing here is just denormalizing the tables. So we're taking the data from one and joining it to the other so that each row has all of the information on it. We don't have to go outside of the data to look things up anymore. In well-designed operational databases, you would normalize the data, which is the opposite of this, where we take, for instance, a person or their address and we put it into another table, and then we just reference that so that it's the same every time, reduces data size, all those good things, improves performance. But here we're doing exactly the opposite, because at this point we just want to look up the information, have it available, and have that performance for reporting purposes, and this is the best way to do that. So again, we're joining into customer data. So here we've joined all three tables so that we get a single table with what was the order number, who was the customer, what did they order. All of that is going to be on a single table, and each line is going to be one row from that order items database. So for every item ordered and the quantity and etc., we'll also show the customer and the order number. Then we're going to just format the date such that it's in year, month, day format. This isn't strictly necessary, but for the purposes of the next demo with Power BI, it's convenient to format this date. And then finally, we're going to do a select statement, and we're going to remove all of the data that we don't need here. So as you can see, we've got the order ID in twice, so we can delete that second one, which is source order items order ID. We're keeping everything from the orders table rather than the other tables. And the source customer ID we don't need because that's also in the other table. And then we're just going to remove some of the extra information that was in the customer table that we don't need in the final model. And quite a lot of this is removing data that we're not going to consume later for performance purposes, to keep costs down. When we load this into a memory resident database, the more data that's there, the more expensive it gets because we need larger SKUs of those services. So we always try and reduce the data as much as we can and make it as compressible as we can. So another thing that we do there is where we've got a timestamp with the year and the date and the time, we might remove the time from that because it's harder to compress. There are less overlaps and repetitions. If you're just using the year, month, day, then that's going to compress better because everything will fit in within 365 days in a year, and therefore because they show up more than once, we can compress them really well. So that will be smaller in memory and therefore cheaper. So again, we're just going to sync that out onto disk for that new table, again to a single file. And again, we're optimizing to a single partition. So I didn't explain that option earlier. This means that when we run this, it's actually only going to run on a single node. Because we're writing out to a CSV, it's not a particularly advanced file format. So we're having to lock it down effectively into a single node to do the processing so that when we output it, nothing goes wrong with the data. In normal processing, you would probably end up having it much more parallel because you're going to want it to scale outwards across a cluster. So here we're putting on two new branches. We're going to create more aggregations. And these are things that we're just going to be able to look up in Power BI. So I want to be able to see in the month of August, how many of these did I sell, that kind of thing. And part of the purpose of this is that we can pre-calculate those things, do that once, store it in the database. That means that when you open a Power BI report later, these are just going to come up instantly and you can immediately see that data. It also means it's only calculated once, so it's much smaller systems required to see this. So this particular one that we're looking at now is the count of a city. This will show us how many orders were there for a given city in a given month, that kind of a thing. You can see at the top there it's grouped by city.date, which means that we're going to get a line for every city for every month that's coming through. We're then doing the same with items, and we're also going to toss up the totals. So in Power BI, I'll just be able to say, show me the total sales for this month, and it'll give us the figure straight off. And you can see here we've got the to float in there. This just puts it into the correct variable type so that Power BI knows that it's a decimal number rather than a integer or that kind of thing. And sometimes we have to correct these things as we're working through. So again, we're onto the item table. We're doing aggregates here again, exactly as we did for the cities table. So we're just doing some counts and some I think maximum items and minimum items, so that we can very easily look these things up. And these are just examples that I came up with for the lab. So max quantity is going to show us the biggest order for bananas was this in March, for instance. And then we're going to add a similar one for minimum quantity. But it gives a good example of the various metrics that we can measure and that we can configure at this level while we're doing the processing before it even gets to that presentation layer where you're going to consume this and put together your reporting. So finally, we're just going to create syncs for each of these two, and those are going to be exactly the same as the previous syncs. We're going to use the name AGGR on these for aggregation, just to show that they're aggregated tables. They don't contain the detail, so they're much smaller tables. We can load them faster. And in the next lab, we'll be loading these into Power BI. But if we want the individual data, we're going to actually go to SQL DW to get that information. So if I wanted to see the line items on somebody's order, I would be going back to the database. Whereas if I just wanted to see what was the general number of orders this month, then I'll be able to see that straight away in Power BI. So exactly the same process. As I said earlier, this is quite repetitive. It's quite a long and sort of almost a tedious lab to set up. But sometimes, you could have 100 tables, these things need doing, but it's not a difficult thing. As you can see, we're effectively copying the same thing each time. Behind the scenes, this is all JSON code. So actually, if you're doing this in real life, you would be able to copy and paste a lot of this stuff rather than using the interface. We also do have an alternative Lab 3, which is based on Databricks, which is another very popular way of working, or Apache Spark. And that's all code based in Scala or Python or that kind of thing. And again, you can integrate with Git, you can copy and paste code here and there. So the way you'd actually work with this on a large project might be a bit different, but for the purpose of this lab, we're just showing, because it's very visual, you can see on the screen the kind of flow of the data. So it's nicely presented. And if we click this button, then we can actually zoom out and see everything that's happening on one screen. And obviously we can move around on that and see what's going on. So finally, we're going to publish. Data Factory is going to tell us everything that's changed. And once that finishes publishing, we're just going to do a run of the data pipeline. So as we did before, click back onto the pipeline page and then add a trigger and just trigger now. So obviously in real life, we would never use the just trigger now option. You would always go back and set up a regular trigger so that this data is refreshed automatically and that the database has got the latest information in. And quite often that's one of the more time consuming things, is working out how to deliver the data fresh every day correctly. So again, this sequence has been sped up as I've shown on the screen there. And what we'll see here is it takes a little while for the cluster to start up. This is starting a Spark cluster in the background. So we can see on the screen here that actually took over 4 minutes for the cluster to start up. It's not a great deal of time in the grand scheme of things. This means that we're not running the cluster 24/7. And then you can see on this screen all of the totals of rows that were processed, where those went, and how long it took individually for those. And you can see that actually it took much less time to process the data when compared to starting up the cluster. If you have a larger data set, obviously that would flip the other way around. So here we're just looking into one of those aggregate tables, and you can see each of the cities has a line and it's showing the date, and those will continue all the way down, and there'll be a line for every city on every date that's included. And again, here we can just see the cities table that contains just that city information. So I hope you enjoyed the demo. We've now got the full model on the lake. We've got aggregations in there, we've got fact tables, we've got dimensions. We've extracted what we needed from the source data, from that sales database, from that weather information. And now we are going to go on to pull that into a presentation layer and actually do the presentation on it. So please check back again for Lab 4, which is coming up very soon, and then Lab 5, which will be coming along shortly as well. Hit the subscribe button so you don't miss those, and I will see you next time. Thanks very much.